Hello, welcome everyone again. Thank you for the time that we wait the next people to join us. And please let me inform you about the webinar terms for today's editions. As usual, the headphones will be shut down to avoid any interruptions. And in case you have any questions or comments during the presentation, we will do the following. We'll proceed the following way. In the lower right corner of the menu, you have to choose the activities options, and then you can see it says questions answers. It's the button number 4. Yes. Once your question has been formulated, we will wait and answer it during the interval for this purpose. And all the questions that has not been answered during the webinar, we will do it as usual by email. And also you can contact us, sending more inquiries to us to our email address, which is info@pathgroup-sa.com. Okay, now let me introduce you once again to the professor and pharmaceutical degree, Mr. Arturo Hoya. He is in charge of this dissertation today. Arturo is a very experienced pharmacist. He has large experience in R&D and production area and more than 30 years experience in Vago laboratories. He's really a prominent pharmaceutical, which is a prominent pharmaceutical company among others. And well, please, Arturo, it's your time for the dissertation. Yes, hope everyone can listen to him and enjoy it. Yes.
Good morning, Mauro. Thank you very much for introducing me, and welcome everyone. And thank you to hear our fourth webinar about solid technology of product. And well, today in our fourth webinar, we tried the dry granulation line. Dry granulation is one of the three main technologies in order to produce the intermediate product. Intermediate product is for us the product that will be dosified in the tablet machine. So for us, it's very important that the intermediate product have good characteristics in order to enhance the tableting production. Let me show the presentation. Give me a minute, please. Excuse me. I have a problem. Okay. Please let me know if you can see the presentation.
Yes, Arturo.
We can see it, Arturo.
Thank you. Okay, this is our for webinar, the dry granulation line. So we have to see the sequence from the raw material to semi-finished product in the dry granulation line. Of course, it's very important for us. Remember that our vision about the production process is with the perspective of product quality and process efficiency. This is our focus because it's very important in these times of the high competitivity between companies.
Sorry, Arturo, if you can expand the size of the presentation so we can see it in complete way. Now we can just see it as a PowerPoint.
Okay.
Will be much better. Yes.
Okay.
Thank you very much. Now it's
Okay,
better.
okay. Excuse me. Well, the sequence of the general sequence from the powder to coated tablets is this: API and excipient first produce the intermediate product. This intermediate product will be tableting in the tablet machine and then coated in the perforated pan. These two steps, tableting and coating, will be presented in the next webinar, the 5 tableting, and coated tablet in the 6th webinar. But the technologies for produce intermediate product, blending or granules, are these. Remember, these are the main table that show the general process, the main process of produce intermediate product, the direct compression, the dry granulation, and wet granulation. Direct compression was presented in the 3rd webinar. Wet granulation was presented in the 2nd webinar. And today we'll see this, dry granulation. Dry granulation, we have different modes, but today we'll try the dry granulation by compaction. This. And compaction will be conducted by rollers compactor or by the mode called slugging. Slugging is the tableting in a tableting machine with tooling with big faces and diameter. Well, when we look a survey about the main technologies uses around the world, we see that these figures: direct compression 20%, wet granulation 70%, and dry granulation more or less 10%. Some countries higher, some countries lower, but this is more or less the distribution of these 3 main methodologies. Well, but where we apply this granulation process, dry granulation process, the application? Well, first of all, dry granulation is ideal for API sensitive to humidity and heat. So, because this methodology avoids hydric stress and thermic stress, it's very important in the case of very sensitive product. For example, maleato de enalapril, for example. The second application is in material highly hygroscopic, such as plant extracts. This is a very common usage of dry granulation. And the other suitable is for formulation with a high proportion of API with low flowability. Remember, flowability is one of the principal characteristic of our intermediate product, because the performance in the tablet machine will depend of the good flowability. So if we have a formulation with high levels of API with low flowability, well, the performance will be bad in the tablet machine. So dry granulation could solve this problem. The other possibility is for dry granulation is suitable for some formulation with a high proportion of API with low compactability, the other characteristic that the intermediate product have to have, because if the powder have low compactability, the tablet during tablet compression will be fragile, low hard, etc. So, why I say for some formulation? Because when the API is in high proportion, but the API is or have plastic deformation, no fragmentation. In these cases, API with plastic deformation, probably this technology will not a solution. So, for some formulation where the API in high proportion is fragmentary, in this case, dry granulation will have a good performance. So, well, this is a general application of dry granulation. Is good for these cases. Well, but dry granulation is presented as a compaction because dry granulation means the application of mechanical energy in order to bind the particles of the powder, the fine particles of the powder, into granules. First, produce a briquette, a big compact, and then the milling, the grinding, will have the granules. But this compaction, this apport of mechanical energy can be done by roller compactors or slugging. Slugging means a tableting in a tableting machine, the classical tableting machine, but using a special tooling, normally round, a big diameter, flat tooling. Both of this mode, roller compactor or slugging, are used, but of course, rolling compactor have a lot of advantage over the slugging. So compare both equipment, roller compactor versus tableting machine or slugging. The general comparison showed that roller compactor is a continuum process, but tablet machine is a batch processes. Roller compactor have high productivity and tablet machine low productivity. And of course, rolling compactor no need scaling up because we have the development made in the same equipment than the production. But in the case of slugging, high variability in compact characteristics avoid or complicate the scaling up. Another question is the comparison of specific characteristics of roller compactor and slugging. For example, let's see this difference. In the case of roller compactor, the distance between the rollers, the center of the rolls, is X. X is the gap between the rolls. This X is variable, is adjustable during the process. In the case of slugging, You know that when you fix the roller of the tablet machine, the distance between the tip of the tooling is constant. Y is constant during all the process. And this is very important. This aspect, I constant, Y constant, and X variable is very important because will impact in the characteristics of the granules obtained. Let me show you this comparison. Roller compactor, tablet machine. For example, toolings. Roller compactor have two rotating rollers. One of these rollers is a flotating rollers that permit to a variable distance between rollers. In the case of tablet machine, punches and dies have a constant distance. The other question is the distance between rollers or punches. X variable because one roller is free. This is called the gap control mode. You fix the gap distance or gap, and this will vary as a function of the feeding of the powder. And in the case of tablet machine, Y is constant. The other difference is powder feeding system. In the case of roller compactor, a hopper has a screw that feeding in a constant way to the zone of compaction. In the case of tablet machine, you have only the hopper and the gravity, no more. So the powder filling between rollers or within dies will be, in the case of roller compactor, uniform and regular, but will not uniform and low flowability in the case of tablet machine. So what we will obtain during the process is that the compaction pressure will be constant if we use a roller compactor, and will not be constant, will be variable in the case of tableting machine. And it's very important question because the uniformity of compacts, the briquettes, will be uniform in thickness and length when we use roller compactor. But when we use slugging, will not uniform because the pressure applied was not constant, was variable. This is very important because the granules we will obtain when the grinding and milling will be uniform in the roller compactor and non-uniform in the tablet machine. We will see this in the next slide. But these are the specific differences between the roller compactor and the classic tablet machine in mode slugging. Of course, the final tablet quality will have uniform for the roller compactor and non-uniform in the case of tableting machine. Well, these are the machine design and compaction mechanism. We have at the top the area of the powder feed area. The powder move to the compaction area between rollers. As you can see, you have the screw, the vertical screw, that force the feeding, and this is very important because this is uniform feeding that let the machine feed the rollers in the area of compaction. The next area is the compaction or lamination area. Here the powder is compacted by the rollers and form the compact sheets or briquettes. Remember, these compacts, these sheets, these briquettes have a uniform density, isotropic, because the pressure was constant, and the pressure was constant because the gap is variable in a function as a function of the feeding. More feeding, more powder feeding, the distance of the gap will increase and the pressure will be maintained at constant value. This means that the deformation produced at constant pressure will the same, independent of the feeding of powder. After obtaining the compact sheets or briquettes, a grinding in the same machine will occur, the grinding and the sieving area. This will define the size and the size and particle distribution of the granules. This is very important question. So in the same equipment, we have 3 steps: feeding, lamination or compaction, and grinding and sieving. So we obtain the granules that then will be blended with the extra granular excipients, lubricating, and going to the tablet machine in order to produce the final tablets. Well, here we want to show you the friction between the powder and the surface of the roller that moves the powder toward the compaction area. Let's see the powder from the hopper and the screw that moves the powder slower than the roller, and in this area begin the friction of the powder with the surface of the rolls, and in this area the powder begin to densify, and in this part, in the gap, the minimum gap, will occur the most densification and consolidation of the briquettes or sheets. This is the nip area, and we can change the condition of alimentation of the feeding and the roller speed in order to enhance the performance of this process of compaction. Well, here I want to put some question about this uniformity of pressure or applied force to the powder. This is the very important question, that the powder feels uniform pressure in all the process. So changes in the amount of powder that reaches the compaction area do not produce large changes in pressure or compaction force. Why? Because the equipment had a rule, one of the 2 rules. One rule is moves. So if more powder enter between the rolls, one of the rolls will move and the pressure will be constant. In this way, the pressure applied to the powder will be constant, transform the powder into a compact object with uniform density and with a good characteristic of isotropic along the briquette. So this type of briquette with uniform density when are grinding, will form granules of uniform density. And this is the big difference with the slugging. In the slugging, you have the volume of dosification constant, because Y is constant. So if more powder enter the die, the pressure will increase. And if the lower power enter the die, the pressure will decrease it. But this variation in pressure, in compaction pressure, impact in the binding of particle, impact in the hardness of the briquette, and of course will produce variability in the density of the granules, and this will have an impact in the particle and size, particle distribution, and in the hardness or compactability of this kind of powder. Well, these are the roller compactor and the operating variables. You can see that you can adjust the screw feeder speed, much or lower RPM. You can modify the roller speed. You can modify the roller gap, and the roller surface. We have a lot of type of rollers. I will see you. The grinding speed of the briquette, and of course, the screen types. The whole of the screen types are important because we'll define the residence time into the grinding machine. So these are 6 operating variables you can modify experimentally in order to optimize the process. And you have monitorable variables that are roller gap and, of course, compaction pressure or force developed during the process. Well, here we have a stop.
Arturo,
Yes, sí.
Sorry to interrupt you. I would like to make just to wait a little bit because we have some questions that we have received, and it will be a good moment to answer it now, okay?
Okay.
Before we proceed with the questions, please remember that we have activated some questions on the webinar attendees that you need to complete the survey. Yes, we have some questions on the survey, and it will be good that you can answer. Then on the following slides, we will activate again some more questions for you. If you can do it, please go ahead. It's on the right part of the screen. Yes. Now, let's proceed with the questions that we received, Arturo. The first one, it says, why it's not necessary to scale up the compaction in roller compactors?
Okay. Yes. The roller compactor process, the development of a product in the roller compactor equipment can be done directly. The development can be done directly on a production equipment with a minimal amount of powder. So you have a big machine in the industrial plant, and you can produce the development in this same machine. So this is a continuing process. So you put 10 kilograms or 300 kilograms, the process will be the same. So this is the reason by to explain the possibility to develop the product in the production machine. So you avoid the complicated process of scaling up. This is the question.
Okay, thank you. I think it has been really, really clear. And then we have another question from Anna, which says, if it is a technology used for high amount of IPI in final formulation in case of IPI with poor flowability and or compactability, the productivity, it means kilograms per hour, depends a lot on the characteristics of the IPI itself. I am right? Could you please explain?
Yes, it's a good question. But powders with a high percentage of IPI with low or very low flowability probably have good performance, good productivity, but in the case of high percentage of API with low or very low compactability, the productivity in this case, in the case of low compactability, will depend of the API deformation mechanism. Let me say this. When the API is in high proportion, and have low compactability, and the main mechanism of deformation is plastic deformation, so probably the dry granulation performance will not be good. This is due to a bad reworkability, the plastic powder, because you have two compaction. The first is in a roller compaction or in slugging. In this process, the plastic API lost part of the compactability they have. In the second compression, in the second compaction in the tableting machine, they will have reduced this compactability. So I resume, if we have high percentage of API with low or very low flowability, no problem. The roller compactor will be a good possibility to enhance the flowability. But in the case of compactability, if the API is mainly plastic, well, in this case, probably you have problem in the reworkability in the second tableting, because in the first compaction, the powder lost compactability by deformation.
Thank you, Arturo. We have a third question from Elena, and she says, if you need to make a plane of pharmaceutical development of tablets obtained by a dry granulation, what parameters will you change first? I mean, what of these 6 parameters are more important for planning of experiments?
Of course, in the development of process, in order to process in dry granulation, first of all, you need to select very well the excipient that will put in the formula. It's very important to be in mind that the filler are the principal excipients. This filler it's important that we'll have a deformation by fragmentation. Let's say lactoses, sugars, phosphate and compress, and product that during the compaction fragment and produce new free area, and a low proportion of fillers that have deformation by plastic deformation. This is about the formulation. So you have an API and try to use fillers with a good fragmentability process, and not use with plastic deformability. This is the first question. The second question is try to produce low pressure as possible during the compaction. We need to apply the less pressure that produce the compact, but not excessive pressure. Why? Because high pressure will produce a high density, and a high density will have a problem during compaction, and when we obtain the tablet, we will have problem with the dissolution process of the API. These are the principal questions that we have to be in mind in order to formulation and in order to operating process. I don't know if it's clear.
Yes, I think it's much clearer now. If not, we will clarify later, because we only have 20 minutes to finish with the webinar. Okay.
Okay.
Thank you, Elena, for your question.
Well, Mauro, following with the webinar, now we have this variable, because the roller type are another variable of the process. We have this roller with the faces smooth or with grooves or different pattern of design. In this case, I have to say that the selection is very empirical. You will try to select one or the other in order to show which is the better for your formulation and your operation. Well, but I have to say about the disadvantages of dry granulation, because not only is good in dry granulation. And let me show you this. First of all, dry granulation could affect the compactability. I told in the before slide. Loss of compactability. Why? Because plastic powder like microcrystalline cellulose or starch or some kind of sugars deform during compaction and lose part of the deformability for subsequent compression, the second compression. So this loss is depend on the applied compression force. So if you apply more force, more loss of deformation. So which is the solution for a formulation that have a plastic powder, plastic filler, or an IPI with a plastic characteristic? Well, this is one use a formula enriched in fragmentary excipients like lactose or phosphate, and the other solution is reduce the compaction force. We will in the next slide an example for this solution. So modify the formula and operate with low force. The second disadvantage is a high proportion of fine powders in the granules. High proportion of fine powders in the granules will conduct to low flowability, and this is a bad news. So we have two possibilities. 2A, if we have an inadequate synchronization between the screw feeding, and the roller speed, this allowed that the fine filtering the powder, and so this affect the flowability. In this case, the solution is, well, adjust the screw under roller speed. This is a very, very empirical question because you have to move the screw velocity and move the screw, the roller speed, and look if the fines filter across the roller gap. The case 2B is for the case of slugging, so in the tableting machine. And in this case, in the slugging, a large variation of hardness strength of the tablet or the compact will determine the formation of fine powder after grinding. Let me say this. Remember, in the slugging, the pressure applied is not constant, it's irregular, it's high variability. Why? Because when the die filled with much amount of powder, the pressure will be higher, and the tablet will be hardness, will have a big hardness. When the die filled with few powder, the pressure will be lower, and the tablet, the compact, will be less hardness. During the grinding, this last compact will give us a high proportion of fine particles. And for this case, we have no solution. And this is the principal difference between the slugging and the roller compactor. Roller compactor have a roll model flotating that permit maintain constant pressure during the process. Slugging doesn't permit obtain constant pressure during the process. So these are the disadvantage and the solution of some of the problem in dry granulation. Now I want to show you the case study number 1. In this case, optimization of roller compaction process, and we will see two examples. One of these is optimization of roller compactor process by adjusting the compaction force. Remember, compaction force is very important in the case of excipient or API with plastic deformation. The second we will see is optimization by adapting the product formula. Well, First, how to optimize the roller compaction process by adjusting the compaction force. Look at this. Impact of compaction force on the compactability of the intermediate product or semi-finished product. We have a direct blending, and we want to compact in a roller compactor. The compaction force we will apply, for example, 0, will not modify the characteristics of the powder. We will obtain the direct blend, of course, is naturally. But when we compact this product at different force, compaction force, we obtain this. In this graph, we will show the tablet harness. These are the final tablets versus compaction force, and this is the dependence of tablet harness against compaction force. But what happens if this blending, direct blending, is compacted with 800 kilonewton? Well, we obtain this kind of granules, but this kind of granules have a different profile of compaction, is lower than the first. And look at this, with 1,200 kilonewton, the performance will be lower too. We have so this kind of compactability profile. This high compactability, and these are low compactability. Here we know that the importance of the compaction force, of course, 0 is not compaction, and 100 and 1,200 is very high compaction force. So we have to use an intermediate compaction force when our formula have a medium or high percentage of plastic component. This is very, very, very important question. Well, the other optimization is by adapting the formula, and I want to show you this experiment for Rodolfo Rodriguez for University of Mexico. He studied the relationship between the hardness of the tablet or tablet mechanical strength versus compaction pressure. This very similar graph we saw in the before slide. And here he demonstrates that when is used, for example, a co-processed of microcrystalline cellulose with phosphate calcium phosphate, the response are with this slope, high slope. But if you use the simple, for example, AB cell pH 101, 102, you have a low slope. This is due to the plastic characteristic of this plastic characteristic of the cellulose microcrystalline. This Avicel DG is a brand of FMC, the company, that is a co-processed between encompress 25% and microcrystalline cellulose, and of course this performance is very important, and is advised that the use of the filler in this case is good because you can apply high pressure and not lost the reworkability or not lost compactability. So this is by adapting the formula. Clearly, the hardness in this case is very, very bigger than this. The abyssal DG has a greater fragmentary deformation and low component of plastic. Well, the case study number 2 is a comparison between roller compactor and tableting machine. These are experimental results from the team of Ecovita group. And in this case study, we will show you, first of all, the effect of type equipment on the dry granulation size distribution. So the impact in the granulometry. And the second, the impact of the granulometry on tablet weight variation in the tableting process. Well, this is the formula that the team used: basaltan, amlodipine, and hydrochlorothiazide, blending in, and compacted by roller compactor and by a tablet machine. Look at this. After grinding, the PSD, the particle size distribution, is controlled. Okay, and obtain this profile of granule particle size distribution. As you can see, roller green and red is tablet machine. What we can see is the fines, the percentage of fines. Fines means size lower than 100 microns, is very big or bigger than the roller, 50% against 30%. So we will wait that the case of tablet machine, the slugging, the product will have a low flowability. And in the case of roller, will have good compactability, good flowability. So this is the first step. And the granules obtained with roller compactor and with slugging, after lubricated and then processed in the tablet machine, show these results. Look at this. In this X tablet weight, the tablet variation weight, and you have in green the roller variation. The roller variation is limited in the normal weight. Why? Because the good flowability. And in the case of tablet machine, the slugging, the variation are very big. And this is due to the high percentage of fines. This high percentage of fines, of course, is due to the variability in the compaction pressure during the compaction. And remember, this is due to the distance in the tips during compaction are constant. If the feeding are different, the pressure will different, so the hardness of the compaction will differ, and after grinding, the slugging, the tablet with low hardness will produce higher percentage of fine, and this impact directly in the flowability, as is shown in this in this graph. Well, the last is dry granulation problems and their possible solution. Problem, for example, high amount of fine material filter. So, first of all, adjust the vertical screw speed, reduce, or roller speed and roller gap. These are three actions you can do if high amount of fine material is filtered to the grinding area. The second solution is recycle the fine powders into the hopper, and but this can affect the uniform flow, of course. The other problem, we spoke about this, is loss of powder compactability. This is a very problematic question. For the first question is reduce the compaction force. Reduce the compaction force to the minimum that form the compact with high or with good hardness. And the other is, well, in the formula, add fillers with fragmentary deformation characteristic. This is the solution. If the problem is not uniformity tablets, well, optimize the fitting, adjust vertical screw speed, or adjust roller speed and roller gap. And if you have roller sticking, this is a particular important problem. The roller, the face of the surface of the roller sticking. Well, in this case, of course, enhanced blended lubrication. Remember, the blending that will be compacted need a low percentage of a lubricant, normally magnesium stearate, but you cannot avoid put stearate magnesium in the blending to compact. You can add more lubricant or enhance the blending. And of course, compaction, again, this could be a solution. It's not the best, but in occasion you have to do this. Well, thank you very much for your attention, and well, questions.
Hi, Arturo. Thank you very much for this second part of the presentation. Before we proceed with the questions that we have from our attendees, let me inform that we have activated again some questions that we need your reply. Yes. Also, I would like to remind that the next webinar will be on July 5th, and this webinar will be related to the tableting of intermediate product. Yes. We will share with you the link for the inscriptions during the following days. Okay. Now let's go with the questions that we have received. We have one question. Give me 1 second. From Osen, and he says, "Hi, where we are using MCC with lactose as filler in our compaction formulation, will it lead to cone effect in tablet dissolution? Is MCC the reason for that cone effect?"
Okay. Osen, you say when you put the tablet into the vessel of the dissolution machine, the tablet go to the bottom and produce a cone of powder. This is the question?
Let's see if we have Osen active. Yes, that's his question. He just replying.
Yes. Okay, Osen. I think that is the MCC are hydrophilic but insoluble filler. So I think that this cone, this powder cone in the bottom of the dissolution vessel is due to the MCC powder that is in the bottom and is not dissolved. But perhaps this is the reason. It's insoluble, so MCC will stay in the bottom during all the dissolution process. I think that is the question. Okay? Okay, thank you, Othen. Sí, yes, Mauro?
Mauro? Mauro?
Hello, can you hear me now?
Yes, yes.
Okay. We have another question from Anna that says, what is the typical working capacity for pharmaceutical or for food products in percentage from maximum compactor capacity? What is some ideal products with excellent compactability, flowability, etc., reach maximum capacity? It's more related with the production capacity of the equipment.
The maximum capacity is it depends of the formulation. The formulation means the fillers, the API, the proportions, the lubrication of this. This is one aspect, and the other aspect is the operating variables we use, the optimization of this. If formulation is good because have a good components, and if the operation is optimized in order to speed of rollers, adequate gap distance, and the screw of the feeder, well, in this case is the maximum amount that let's suppose you can produce between 2 and 5 kilograms minutes, more or less. This is variable, of course, but you can optimize variation, the operating system, and variation, the formulation components. I think this is the good equilibrium.
Okay, thank you very much, Arturo, for your answer. Then we have another question from Mr. Caponi, and he says, "Hi, what is the importance of the design on the roller?"
Yes, in the market, you can see different kind of surface. The smooth is the more common, but the groove are two, and then you have a lot of design of the surface of different patterns. Really, in my experience, I use the grooved faces and the smooth faces, and the performance is very, very well. But I think that depending on the different formulation, you perhaps you will need another type. The manufacturers offer 2 or 3 kind of surface of a roller, but I guess that the groove is the more common and the more efficient, I think. I don't know if you have a specific formulation. For example, if you have a formulation with tendency to sticking, oh, in this case, I suggest, my advice is use smooth faces rolls, because you will reduce the sticking. But if you have not sticking product, well, use the groove faces that will have good results.
Thank you, Arturo. We have another question.
Thank you.
Kamesi, and he says, "Hi, can the roller's design affect the granulometry? Thanks."
Excuse me?
If the roller compactor designs can affect the granulometry.
The granulometry, let's say the particle size distribution, the size and the distribution of the particle, of course, will depend of a lot of variables. First of all, the composition, the formula, and of course, the operating variables. For example, the force or pressure during the compaction. For example, if the pressure developed during the compaction is high, we will obtain compact with a very, very high hardness. And then during the grinding, the particles will have bigger than those obtained from the tablet or the compact with low hardness. So you have to empirically find the optimal force. The compaction force is the most important variable in order to define the PSD, the particle size distribution of granules during the roller compaction. Of course, the formula too, but I think pressure is the more important.
Okay, well, Arturo, thank you very much. It's already 12:11 here in Barcelona, so we are almost on time. I would like to remind that we have the next webinar edition on July 5th, so we hope everyone can participate. We're almost at the end of these webinars. I cannot believe since the moment we start with it, we're almost finishing. So all the questions that we have not answered, we will do it by email. And also remember that you can send us some queries to info@pathgroup-sa.com. Okay. And well, thanks everybody for participating on this webinar. And well, have a nice day and thank you very much.